All right, good morning. Today we're going to talk about definitions and biconditional statements. So, this is going to be similar to what we talked about with the conditional statement, but there's something special that happens with the biconditional statement. So, our goal and our essential question will be to recognize and use our definitions and to recognize and use biconditional statement is what we're going to focus on today. Right? So you should know about perpendicular lines already. So two lines are perpendicular lines if they intersect to form a right angle, right? So this is how you mark perpendicular lines. So if two lines intersect like this, then you indicate that that is a perpendicular by marking the little box there. So that's how you know that these two lines are perpendicular because it forms a right angle there. And then obviously it forms right angle on all four corners, but you don't have to put all four, just put one, right? Now, so what happens if the line is perpendicular to a plane? So here's a kind of a picture to show you if a line just goes straight down to a paper, which represents a plane here. The line perpendicular to a plane is a line that intersects the plane in a point and is perpendicular to every line in the plane that intersects it. So what that means is that I drew a couple of lines here. So this perpendicular line to the plane is going to be perpendicular to every line as long as it intersects right here at the same point, right? So then the biconditional statement is what we're going to kind of focus on today, is a statement that contains the phrase if and only if. So that's the magic phrase, if and only if. Remember last time we talked about the conditional statement with if and then, right? So the biconditional statement has the phrase if and only if in the middle of the sentence. So you'll see examples of that, okay? So, this should be kind of easy, but we're just looking at the picture and determining whether these statements are true, right? So here, the angle KLJ. So angle KLJ is this angle right there. That's 36 degrees. And angle KJL. So KJL is this angle here, which is 54 degrees. Well, are they complementary? Complementary means adding up to 90 degrees, right? So if you add 36 plus 54 degrees, does it add up to 90 degrees? Yes, it does, right? So that is true. They are complementary because complementary means they add up to 90 degrees, right? Now, what about B? Line KL and line LJ are perpendicular. Well, line KL is this line here. Here's K. So KL is this line here, right? So that's line KL. And line LJ, L is here, J is here. So that's this line that connects L and J. So then it's going to intersect right here. Well, is that perpendicular? Well, no, because perpendicular means it's going to form 90-degree right angle. Well, this is 36 degrees, so that's false, right? The last one, the angle MKJ is a right angle. So MKJ is this, M is right here. So MKJ is this angle here, MKJ. So we're talking about this angle here. Is that a right angle? Well, true, because we have the right angle on the opposite corner. Remember, these are vertical angles. So the vertical angles theorem tells us that all the vertical angles are always congruent. They're always same. So since that is a right angle, then the vertical angle, the opposite corner, which is the angle MKJ, is also a right angle. So that is also true. Okay, so you could tell by the picture and determine whether the certain particular statement that I'm telling you is true or false, right? So that should be easy to tell, right? So that's the kind of the answers and the explanation that we just went over. So then here are a couple of examples here that we can do. So this one is saying angle KJL is an acute angle. Acute means less than 90 degrees, right? So angle K is right here, J is right here, L is right here. So KJL is this angle that we're looking at, which is 54 degrees, right? So is that a acute angle? Yes, that's true because 54 degrees is less than 90 degrees, and that's what we call acute angle. Right? Now, point N is in the interior. Remember, interior means inside of the angle. So point N is right here, right? Is that in the interior of angle KLJ? So KLJ is this angle here, right? So if we were to continue, right, we don't stop here. I mean, the angle continues with the two rays, but even that continues forever, is N inside of this angle KLJ? Well, no, because N is over here on the top. So that's false, right? So that's not in the interior. It's actually on the exterior of that angle. It's on the outside, right? So that's false. So that should be easy to tell, right? So then here's the biconditional statement that we're going to focus on today. So biconditional statement has that magic phrase if and only if. So whenever you see that phrase in the middle, if and only if together, then that's what we call a biconditional statement, right? And so we could write a biconditional statement into a conditional statement that we talked about last time. So we can write that as if and then. And then we can switch it and write it as a converse of the conditional statement, right? And so biconditional statement can be separated into two different statements. The one is just the original conditional statement, and then the converse is switching it. So if I write this, so let me show you here. So this will be if an angle is a straight angle, then its measure is 180 degrees. So you just kind of write it in order using if and then, like we did last time, right? Now the converse is to switch the hypothesis and the conclusion. So if the measure of an angle is 180 degrees, then the angle is a straight angle. So biconditional statement has the phrase if and only if, and you can separate that into two separate statements, the conditional statement and the converse of that statement. And what happens is you have to determine if both of these statements are true. If both of these statements are true, then that's what makes the biconditional statement true. If one of these is false, then the biconditional statement is also false. So what that means is that biconditional statement using the phrase if and only if is only true if the original conditional statement that you can make out of that and the converse are both true. If one of them is false, then the biconditional statement is false. And obviously, both of them are false. Then it's obviously false, right? So is this true? Yeah. So the angle is a straight angle, then its measure is 180 degrees. Well, that's true, right? And the converse, if the measure of an angle is 180 degrees, then the angle is a straight angle. Well, that's also true, right? So if they're both true, then that's what makes this biconditional statement true as well, right? So that's how we write the biconditional statement using the magic phrase if and only if. Just know that you can write two different statements out of that, the original conditional statement and the converse. And if they are both true, then that's what makes the biconditional statement true, right? So let's take a look at an example here and see if this is true, right? So is this a biconditional statement? Well, it has that magic phrase, if and only if, so that is true, right? So it contains the magic phrase, if and only if, so that's true, right? Now, go here. So if and only if is the magic phrase, so it contains that. So the original statement here is biconditional. Now, is the statement true though? Well, then you got to write it into two statements. So the conditional statement would be if x equals 2, then 3x plus 5x equals 10x minus 2x. So that would be the uh, original conditional statement. Now, if I do the converse, which means I switch the hypothesis and the conclusion, just switch these two, which is what I did here, right? So if x equals 2, then you plug in 2 here. So 3 times 2 is 6, and 5 times 2 is 10, and then 10 times 2 is 20, and 2 times 2 is 4. So that's 16, and that's 16. So original statement is true, right? So the first statement, the original statement is true. However, the second statement is false because if I just solve the original, the left side here, the hypothesis, that would be 8x, and that would be also 8x. Now, this is what we call the identity statement. If you remember from your algebra class, if you have exactly same thing here, right? 8x equals 8x, and I can try to, combine the x's together. So if I subtract 8x equals 8x, then you get what's called the 0 equals 0. This is still identity, which means that solution is going to be all real numbers, not just 2. So x could be 2, but x could be 3, x could be 4, x could be 5, 6, 7. It could be all real numbers. So this is not the only solution or only answer that x could be. That's why it's false. So that means the biconditional statement is also false because the converse turned out to be false, even though the original conditional statement was true. So they both have to be true in order for the whole biconditional statement to be true. So this is false, right? Okay. So you got to be able to write both statements and determine both are true in order for the biconditional statement to be true, right? So here, so we're doing the same thing here. We're trying to determine if this is the statement, and then we're writing the converse, and we're trying to see if they're both true. And if they're both true, then we can write a true biconditional statement, right? So if square root of x is 1, then x equals 1. The converse would be if x equals 1, then the square root of x is equal to 1. So let me show you that here. So the converse would be just switching the hypothesis and the conclusion. So we just switch that, right? So we switch the hypothesis and the conclusion, right? And so they're true. The converse is also true. If x equals 1, then the square root of 1 is also 1. So the converse is true, right? So the original statement, we're assuming that this is all true, right? So that's true. So the converse is true. So then the biconditional statement will also be true. So then we could write the square root of x equals 1 if and only if, that's the biconditional magic phrase, x equals 1, right? So then this biconditional statement would be true because the original statement, we were assuming that it's true, or we said that it was true. And then the converse turned out to be true as well, right? Now the second one, if two angles are vertical angles, then they are congruent, right? So vertical angles are congruent, so this is true. Now the converse, we switch this, right? We switch this to the front, so that's what I have here. So if two angles are congruent, then the two angles are vertical angles. So we switch the hypothesis and the conclusion. But this is false, right? So we have a picture here. We have two angles here, which is 45 degrees and 45 degrees. They're congruent, but are they vertical angles? No, they are separated here. So the converse is false, which means that the biconditional statement would be also false, right? So then we didn't write the biconditional statement because we were only writing the biconditional statement if it was true, right? So that's how you determine if the biconditional statement is true or false, because the original statement and the converse has to be both true in order for you to be able to write a true biconditional statement, having that magic phrase, if and only if. Okay. So here, a couple more examples that we can take a look at here. So we want to rewrite the following biconditional statement as two separate statements. The conditional statement is the original statement that we've been talking about, and then its converse, right? So this one has the magic phrase if and only if. So that's the biconditional statement. So the conditional statement would just be writing as it is with if and then. So if two angles are supplementary, then the sum of their measures is 180 degrees, right? And then both statements would be true, right? So the biconditional statement is also true, right? So let me show you here. So the conditional statement is if two angles are supplementary, right? Here's the magic phrase, if and only if, then the sum of their measures is 180 degrees. The converse of that would just be switching these two parts, right? Switch the hypothesis and the conclusion, switch that to make it into a converse, right? So we write if the sum of their measure is 180 degrees, right? Then the angles are supplementary, right? So they're both true, right? Okay. So the original statement is true, the converse is true. So then both statements are true. So therefore, the biconditional statement is true. Okay. All right. What about the next one here? Two segments are congruent if and only if, again, so here is the magic phrase, if they have the same length. Well, is this a biconditional statement? Yes, because it has the magic phrase if and only if. Is the biconditional statement true or false? Well, it's true because if you were to think of it as two different statements, if two segments are congruent, then they have the same length. That's true, right? And then the other way, converse, if they have the same length, then the two segments are congruent. They're both true. So the biconditional statement is both true. Okay. All right. So that is the notes for today. So hopefully you have a better understanding about biconditional statement, which has the magic phrase if and only if. And it's only true if both the statement, the conditional statement, and the converse of that statement are both true. Okay. All right. Thank you.